welcome guys. So here comes our math section 56. So 56 is the second difficult question I think in this exam, because it's asking about a set called derived set. So derived set is less common in the topology. Usually in topology, people remember the open sets, closed sets, connected Hausdorff, but not something weird object called derived set. Okay. So it took me a while to remember what's derived set. Okay, so let me remind you guys. So there's a topology space called X, and CLS means a closure. So derived sets is defined to be X belongs to X such that when you when the S, let me see, when the S kill this small x, so this kill small is the closure of the least points. S belongs to this, so we do all the collections of this type of points. Then it's called the derived set. It's weird that maybe you don't understand what it means. So basically, it means that suppose. Okay, so we suppose X belongs to large S. Then once we kill this X in S, so basically this is S. Suppose you kill this X, so the X disappear, but the closure of the rest can still contains X still contains in the closure of the rest. So this means that once you kill these points, you can still find another point in S, which approach these points very closely. So if this point has this property, we call it limit points, and we collect all the limit points. So basically, this is a set of limit points. So limit points means that once you kill it, these points can still be approximately by other points. These points can be approached infinitesimally by other points in a set. Okay. And the one important fact is, so one confusion is that the derived set is different from the closure. So one example is if S is defined to be 0, 1, open interval 0, 1, union 1 point called 2. Okay, and what is a closed set? So everyone knows about closed set. Just change the open interval to a closed interval and a union 2. What is the derived set? So derived set. So any points in a 0, 1 is derived set, because even though you kill this point, then this point can be approximated infinitesimally by other points. Right, so this is still 0, 1, but 2 is not the limit point, because once you kill 2, there's no other points which can approach to that point. So you see the S prime and the S bar are different. Okay. So up to now you understand what it means by derived set. Okay. Then we can see that first one say that the AB derived set is A union B derived set is A derived set union B. Unfortunately, this is proved in the Wikipedia, and the problem is because this is technical that I cannot just I cannot explain to you, but you can go to see it. Basically, you just use some common results and definition, and you can prove this. So the first statement is correct. The second statement says that the A intersection B derived set is equal to A derived set intersection B derived set. This is false. This is common question that usually so when you do the intersection, the limit point, the behavior of limit points is hard to predict. So for example, if A is a 0, 1, 0 and a 0.5 open interval, and a B is a 0.5, 1. Okay, so the derived set for this one is open interval and closed interval, and the derived for B is derived set is the closed interval. Okay, then A intersection B is empty. So when you take the derived set for empty set, is still empty. Okay. But the derived set intersection with the A derived set intersection with the B derived set. So you have 1 point, right? So this is definitely not the same. Actually, one can show. So one can show this. And to prove this is not difficult, because you know that basically, so there's a lemma. If A is a subset of B, then A derived set is subset of B derived set, and I think this can be seen by the definition. Okay, so this is I think this is trivial. So A intersection B derived set is in A, and A intersection B derived set is in B. So you combine these two, you get A derived set is in intersection derived sets in an intersection with A derived sets intersection with B derived set. Okay, so the first one is correct, and the second one is false. And the 3 said that A prime is empty. A prime is empty, then A is closed in A. This is definition, right? Because in the closure, you know that A closure is A union A prime. So if A prime is empty, then A bar is A. So A is closed. Is it okay? Okay, so number 4. Number 4 probably is the tricky one. You say that A is open in X, then A prime is non-empty. So this looks correct, right? Because if you think in Rn, suppose you have an open disk. If you have open disk, then the derived set is the boundary of the disk. If you have an open interval, the derived set is the boundary. So it looks like derived set always exists when A is open. However, for the general topology, this can be wrong. Right? So the simple usually the simple contradiction, the simple strange topology is a discrete topo. Suppose you have X is non-empty, I can define a distance. If X is not Y, then distance 0. F is not Y, then 1, then X 0 is. So this is the discrete topo. And the common fact is that any subset in X is closed and open. I think I proved this fact in some other GI videos, but you can directly Google it and you can find it. I think this statement is correct. Okay, so basically, if you take a point like X, okay, the point X, take any point in X in this, then this is open. The reason why it's open is B, because this is X, and other points different from its. Okay, so to prove this is open, we only you can see, because this is open, so I can take the epsilon equals to half. Then this open ball only contains 1 point, which is the point X. So by definition, there is open ball contains only 1 point. Contains only content. There's open ball inside the set. So when you take epsilon equals to half, then this open ball this open ball only have 1 point. This x, so x belongs to this set x. So this is open. But what is the derived set of this? What is the derived set of this x? There's no derived set, because once you kill x, then there's no other points which you can approach x, right? So the derived set is empty. So once you kill x, because discrete topology means that every point has its own connected component. So once you kill one of them, then there's no other point which can approach this point, right? So let's say the first statement is false. So the correct statement is the first one and the second one. So the answer is B. This is the second difficult problem in this test, and then we will see another strange topology problem in the next in maybe in a 60 or something. I think these two are very difficult. So if you give me 3 minutes, then I cannot tell you which one is correct. So be sure to subscribe to my channel, and if you think I'm doing something wrong, then please leave a comment, and I will go to check it. Thank you.